Everybody, happy Monday afternoon to you. I'm meteorologist Nick Dunn here to break down what exactly led to this morning's snowfall being such an overachiever across the Miami Valley. A lot of us getting at least double what the forecast called for, and you may be wondering what exactly happened. We called for 1 to 2 inches of snow, and a lot of us getting 2 to 4 inches. Well, let's dive right in, starting off with a look at our surface analysis on the left-hand side of your screen. This dashed brown line that you see, this is a surface trough. It's not an area of closed-off surface low pressure, but it's an elongated area of lower pressures that we do see. And then you find these black lines. These are isobars, or lines of equal pressure, and where they bend backwards like that to give us that C shape that you see on the map, that helps us to get an approximate idea as to where that surface trough could be located. And we also have to look at the wind direction. So in many cases, north of the trough, you found winds coming out of the north or even at times the northeast. And then you work to the south or in advance of that trough because it was moving southward, and those winds were more westerly in nature. And we talk about a term called frontogenesis, and in this case, we had an elevated amount of frontogenesis across southwest Ohio, not just this morning, but as we work even across the northern parts of the Miami Valley, we saw some elevated numbers there and ongoing at about the same time as the primary band was working through parts of the Dayton metro area. But of course, through the overnight hours, there were some elevated numbers off to the north, and again, it was pretty close to being almost exactly co-located with that surface trough. So a couple of things working together, that trough providing a little bit of lift for some precipitation to get going, and then this term frontogenesis allowed for some of that banding to really accelerate and give us a pretty healthy amount of snowfall. So what exactly is frontogenesis? Well, it's a process that describes either creating or intensifying a frontal boundary. In this case, it would have been that surface trough that we were tracking moving in. It involves a sharpening of the temperature gradient. So at the surface, understand that we have to look at temperatures aloft in Celsius. So at the surface, our temperatures were about 3 degrees below 0 Celsius, or in terms of Fahrenheit, as we all know, was in the middle and upper 20s out there this morning. At 925 millibars, these dotted blue lines that you see, these are isotherms, or lines of temperature, and you notice how quickly we change from about -6 to -8 degrees Celsius, pretty tightly packed gradient there. And then at 850 millibars, very similar result, although we're colder at -10 to -11 degrees. So we're already cold at the surface, but we're steadily getting colder as we're working through the first 5,000 feet within the atmosphere. As we continue, it's not just about the temperature, but it's about the wind flows. We talk about convergence, or winds that are coming together, or divergence, they spread apart. And again, we're talking about the directions. And so we talk about winds converging into that trough here this morning. Pretty evident that we can find that, especially at 850 millibars, a nice curvature with winds coming out of the northeast, changing to the northwest in particular, kind of feeding into where that band of snow was ongoing. And at 925 millibars, we saw some curvature within the winds, but I think it was a lot more pronounced at 850 millibars in particular. Now, I say all this because that is helping vertical motion within the levels of the atmosphere. As we start to get air to rise, it cools, it condenses, forms into clouds and precipitation. And as long as that process is efficient enough, we can see those bands of snow continue to kind of help keep themselves together for several hours. That's kind of exactly what we saw this morning across the Miami Valley. So what does it look like on the map? We look at 925 millibars. That frontogenesis was pretty healthy across a good portion of the Buckeye State, especially right along and to the north of that I-70 corridor, extending down into parts of the Hocking Hills region. At 850 millibars, again, it was a little stronger here across parts of southwest Ohio than everywhere else. Again, just looking at that 850 millibar altitude at 5,000 feet, those temperature gradients were pretty tight. The precipitation was able to band well thanks to those elevated amounts of frontogenesis in place, a good supply of cold air aloft, and of course we had that trough also interacting in, giving us that extra little bit of lift for those bands of snow to really get going. And in some cases, the band of snow really just kind of sat still and was just really slow to move as that trough took its time working through. So what did that look like on radar? Here's a look at that for you. I'm just going to kind of let this loop through. You notice this area outlined in white. And again, as of early this afternoon, we're still compiling some reports, but based on some early analysis, this was about the approximate area where we saw 2 to 4 inches of snow or more. Of course, a few spots may have been just a little shy of that, but I say all this to say that amount of snow exceeded the 90th percentile. So within the top 10 possible outcomes, or top 10% of possible outcomes, that's what happened today. A high-end event that we don't always see here with every single system that comes through. And you notice again that band of snow quite healthy, especially down here in the Dayton metropolitan area, down through Xenia and Wilmington. And even before that band got going, there was a decent amount of snow already falling. And you can see how some of that banding came together as well across the northern portions of the Miami Valley initially. Just we don't have as great of radar detection with trying to detect snow at a higher level of altitude there. But of course, they had their own bands of snow there as well. So it all came together to give us our first really healthy snowfall of the season. Definitely got us a pretty good kick in the butt this morning. I know a lot of you probably felt that as you were out and about driving today, but we're still tracking a chance of a few snow showers as we get towards this evening coming off of Lake Michigan. So if you're heading out and about this evening, dress warm, and of course keep that weather app handy with you from WHIO, and of course it'll help you track any snow that works into the Miami Valley a little bit later on this evening. And it's going to be another cold night tonight with the snow that we have on the ground. So have a good afternoon, everybody, and stay safe out there.